Interdisciplinary means it is going to include mathematics, statistics, data engineering, pattern recognition, learning, advanced computing, visualization, uncertainty modeling, and high performance computing. And the goal is to extract meaningful information and creating some knowledge out of it. Okay, so this was the first vision from Maud. And another definition, which is again very important, that is from Berkeley School of Information. They are indicating that the field of data science is emerging at the intersection of the field of social sciences and statistics and information and computer sciences as well as design. So here you can see that social science is also one of the key field which is creating a very important impact in the data sciences. Okay, according to Wikipedia, they claim that data sciences are nothing but it is a continuation of knowledge discovery of in databases. So basically they claim that it is nothing but an extension of KDD, that is basically the data mining processes. And here the extension is due to inclusion of unstructured data. So unstructured data means now all our platforms are filled with emails, videos, photos, social media feeds. So basically all these user generated contents, they are strictly unstructured, and because of that the conventional KDD processes get extended, and now this particular field is emerging as a data sciences. There are O'Reilly media literature available. They claim that basically data science is coming into picture because data is nothing but it is a product. So basically they are more focused towards the utilization of data. So they claim that data science is nothing but it is an application so that we can explore the value from the data, and so that we can make the data more useful for different aspects of our day-to-day applications. Okay, so in this way you can see that it is a multidisciplinary field. Now data sciences are also came into the picture because we are now flooded with various kinds of data. So as it is already indicating that now it is the era of unstructured data or unorganized data. Okay, the second important thing is, since the data is unstructured, unorganized, and it is unlimited, then there are many more requirements to replace human beings for the data interpretation. So here we are looking for more and more automated processes so that data can be interpreted very comfortably, very quickly. So that's why data sciences are in picture. So basically data sciences are nothing but to automate the data analysis process efficiently so that we can enhance the overall learning process. Okay, so basically this is all about data science definition. Or I can also conclude in one sentence like data sciences are nothing but the new methods of making sense to the data. So you can see that how it is multidisciplinary. Okay, so if we talk about the data science landscape, so it is collection of various fields. So there is no doubt if I include like data sciences are collection of physics, collection of nanotechnologies, collection of technologies, collection of mathematics, statistics, information theory, IT, and AI. Okay, if we talk about the area of interest, so basically area of interest is multidisciplinary. If we talk about the techniques, so techniques which we are already using, they all are the integral part of the data sciences are signal processing, probability models, machine learning, statistical learning, database techniques, data engineering part, pattern recognition, data compression, visualization, high performance computing, etc. Okay. And if we talk about the approaches, so most of the time you will feel that it is very easily, and you can explore the approaches based on machine learning, which is nothing but a part of artificial intelligence so that we can uncover the patterns which are available. And we can also make predictive models with the help of this particular data. So who are the role players? So basically, you see there is a very attractive profile which are available nowadays, that is data scientist. So who can claim as as his or her role as a data scientist? So according to Gartner, data scientist is a very versatile position, and it is very difficult to claim a person as a data scientist because it is full of responsibilities. So if we talk about the data scientist responsibilities, or if we talk about the overall role, so it is basically a very important position where the tasks are nothing but to integrate and prepare large varied data sets, and to architect special structures of the data set, to match it with various computing environment, and also fit within various communicating constraints. So this is the task. If we talk about the profile, so he can be a data engineer. He has to be fully familiar with the business intelligence, and he has to be work as a data analytics also. And not only this, but the data scientist should have all the capabilities of working as a expert in the area of statistics. Okay, if we see what kind of expertise he has to hold, so he has to be very familiar with the statistical concepts, with the algorithmic concepts, with the data mining practices, and he has to be very comfortably adopt the various visualization techniques which are coming nowadays. Okay, and one more thing, like data scientist should also have an exposure towards all the emerging technologies. Okay, so basically what we can say that there is no very specific roles available, but whatever is required to provide solution of any of the real-time problems nowadays which are generated because of adaptation of various emerging technologies. So that has to be desired as a skill set of data scientist. So if I see like what are the different perspective of data sciences, so you can see that there are various focus areas. So basically in the first Venn diagram, you can see that it is closely related with the machine learning. Okay, and it is also having the foundation of mathematics and statistics. Okay, and it can be a combination of traditional research along with some area of expertise in within a specified domain, and it can be also in terms of getting more and more knowledge. So more and more knowledge means it is indicating the effective utilization of ethical hacking, where you can explore whatever is hidden for some with some good intentions. So this is one aspect of data sciences. And in general, if you see the another background, another Venn diagram, so another Venn diagram, this one, it is indicating that data sciences are basically supported a lot by the databases techniques. So all data engineering, including data warehousing, can be a foundation for the data science. In another sense, we can say that it is utilizing various aspects of computer science, where not only the efficient computer architectures are important for high computation, but there are many more techniques which are important for data mining and visualization purposes. Similarly, various statistical analysis techniques, for example, uncertainty analysis, for example, pattern recognition, they are also very important if we deal with the data sciences. I have taken another perspective. So in this particular diagram, you can say that here they are taking that traditional softwares can be utilized, traditional research work can be utilized, but it is not enough. Along with this, definitely we need additional flavor of machine learning, then only it all together can become the foundation of data sciences. Okay. And if you see this particular Venn diagram, which is proposed by Erickson, so they are saying that data sciences can be empowered by effective use of graphic designers. So they are observing that there are a lot of things which are required for GUI programmers, for complexity analysis, and for data miners. Then only we can take the effective utilization of data sciences. So if we see all different perspective, so what you are going to observe, like data science is nothing but it is a new perspective where we are trying to integrate all the existing expertise, all the existing trends, and we are focusing towards more and more expertise in any particular field. So it is a multidisciplinary, okay, and it is having collection of various foundation things, like it includes computer science fundamental, it includes all about analytics, it includes data management concepts, it is having a significant role in arts and design, and lot of entrepreneurship inputs are required to be a data scientist so that any current problems we can solve. Okay, so these all Venn diagrams you see, they are having multiple collection of fields. Like earlier it was consisting of four these particular areas, then it became five, then it became six, then it became seven, and now it is more than seven. So basically whatever are the existing trends, they all are merging or emerging with the help of the foundation of the data sciences. So anybody can explore various research opportunities in the field of data sciences, because it becomes like an umbrella, and under this umbrella all the various research questions can definitely get addressed under different perceptions. So again, I am just concluding like what are the very closely related fields. So we can see that mathematics and statistics are very closely related fields. And similarly, programming and databases aspects are also playing a major role. Then we have to be domain experts, and certain soft skills are required, because data sciences are not only in terms of engineering aspects, but it is also in terms of management aspects, because we are managing different domains and different area of expertise. So there should not be any conflict, and we should address all the issues in such a way so that ultimately they lead towards the welfare of the whole society. So basically some kind of soft skills are required, and a lot of role is means it is there is a scope which is towards the visualization part or towards the knowledge creation part. So whatever we are doing, the ultimate goal is to create a knowledge in such a way so that next generations can use that knowledge for their welfare. So basically this is all about the role of the modern data scientist. Okay, so I have one very important observation. Is data science is a maturity science? So maturity science means although we may able to we may able to attain basic functionalities at the very beginning step, but there are always possibility to make it more powerful, more useful, or more optimized. Okay, so what kind of domains that dealt by an intellectual enterprise? So basically there are any enterprises which are dealing with certain topics. So what are the topics? Topics are facts, data, problems, phenomena, observations, etc. And any enterprise, it is also dealing with various methods. So methods are techniques, approaches, etc. And there are certain theories. So theories are nothing but some beliefs, some hypotheses, certain explanations, and some work practices which they are following. Okay, so basically this is the existing scenario. Okay, but what you will feel like there are various possibilities of any new emerging fields where the field has to be very specific or in terms of certain unique topics, and there are certain original approach which are there, but we want to upgrade that original approach in terms of certain innovative approaches. And similarly, we want to upgrade some existing theories in terms of new theories. Okay, so if this is the case, which is possible everywhere, so here the data sciences are playing it's a very important role. Okay, so in any business, there are some technical matters, theoretical matters, certain problems, certain conceptualized analysis, and here we want to make it upgraded, and that upgradation is only possible if we want to open the doors for multiple technologies. So if we are ready to make it more and more interdisciplinary, then only it can get upgraded. So this is what the data science is. So data science is actually, it is helping any organization to be more mature, to be more efficient, to be more optimistic, and to be more strong. So we cannot say that data science is required at any specific field, but it is required everywhere. For example, suppose there is a health organization or there are various healthcare units. So although they are working fine since many years, but how data science can make them more efficient? I think you already aware about it. So with the help of data sciences, we can make them more reliable. We can make it more you can say that optimized. We can make it more versatile. So this is basically the scope of the data science. So basically, data sciences can be applicable to any organization, can be applicable to any application in any field, and it is to it may not be mandatory, but it is very much desirable if we are looking for maturity of that particular organization. So here the data sciences are playing its very important role. If we see the history of data sciences, so I can show you very popular overall roadmap which is proposed by the Gill Press. So you can see that like it started in 1962. Okay, so at the time it was the time when the data importance of data is established. Okay, so in that particular time, there was a journal, the Annal of Mathematical Statistics, and they started this. Like there was an article published by Turkey, and it was the future of data analysis. So you can see that it was the very beginning time when we understood the importance of data. Okay, and then in 1974, there was another milestone publication. It was Concise Survey of Computer Methods. So in that particular publication itself, they highlighted the data in terms of representation of facts or ideas in a very formulated manner so that it can able to manipulate the processes. Okay, so that was the time. Then similarly, in 1977, there was a publication which was entitled as Exploratory Data Analysis. So here, a lot of hypotheses were it was suggested related to the data analytics. Then there was an association, that was International Association for Statistical Computing. They also established that there will be a time when the knowledge engineering will lead for many of the existing applications. So this is the way how data sciences means end up with this particular title. But you can see in 1989, there was the first KDD workshop. Okay, and then in 1994, there was a cover story where actually the database marketing started. Then you can see that there is a very standard publication which is available by FAIRD. So it was From Data Mining to Knowledge Discovery in Databases. So basically the KDD get established in the later years of 90s, where we adopted the term KDD, which was a step-by-step process where the data can be utilized as a knowledge with the help of various steps. Okay. And you can also see in 1996, this data science term was used in one conference. So there was IFCS conference. So they have used the data science word first time. Then there are many more things which get added time to time. So there was a book which was published. It was related to data mining and data engineering, data discovery part. So finally, you can say that by the starting of the year 2000, the data science word become popular. Okay. So in 2003, there was a journal started by data sciences, and in this way, finally, we reach to the particular available status of the data science. So it is not a one-day story, but gradually there are various steps taken where it was nothing but started with the simple term data. Then it comes into the data mining, and after data mining it becomes multidisciplinary because more and more expert areas, they felt that they also need this insight in their own applications. So basically it becomes more and more wide, and later it was established that in 2009, like data sciences are something where it is not only a common field, single field, but it is a field where computer science, mathematics, statisticians, and graphic designers, they all can work together. So this is the whole evaluation of data sciences uh, up to the various stages, and finally we reach to the current state. So after 2012, you can see that the data science as a keyword was clearly established, and it was established in terms of a multidisciplinary field which can support any of the existing techniques with different perspective. So this was the short story of the data sciences. Okay, so now what kind of objective which gets satisfied by adoption of data sciences. So basically we accepted that it is not data which is sufficient, but once the data is converted or mapped into some knowledge, then only the existence of data will be proved. Okay, so here is basically data sciences are useful to empower this particular understanding. So basically there are two contexts. One is the scientific context and second is the philosophical concept. So we can say that there is a very typical journey, like data can be interpreted as information and information can be interpreted as knowledge. So basically the theory of data sciences says that there are many more. So what is beyond data science? So we see like this is the present era of data sciences, but this is just a beginning. Once we complete or exhaust this data sciences, then there will be the scope of information sciences, and then anytime in future there will be the scope of information sciences. So basically you can say that still if you see the previous changes or previous developments, you see that means we came to the long way, but if you see the futuristic possibilities, so you will feel that it is just a beginning. So data science is just a beginning. There are many more things which are possible when we move towards the information sciences and knowledge sciences. So basically you can say that there are three stages of evolution. One is data, second is information, and third is knowledge. Okay. So I'm moving towards for some other aspects. So I think you can say that if we conclude all the important fields, so basically data sciences are supported by various thematic areas where the domain experts are having their own domain knowledge, and then it can be supported by mathematics and statistics, and then it has to explore all the it has to exploit all the computer science strength with the help of machine learning, traditional softwares, and traditional research practices, then this all can become the backbone of data sciences. Okay, so what kind of applications are supported by data sciences? So any application which is data driven. So all data driven applications are basically, it is one basically the area of data science where we can research. And you can feel that most of the activities these days are data driven. So most of the applications are basically data driven. Any application which is of large scale. So large scale means here we are talking about the volume part, means the computational complexity part. So that comes under data sciences. Any application, if it is shared application, or if it is of multiple people interest, so where there are a lot of communication required, lot of cooperation required, or a lot of collaboration required, that is actually a data science problem. Any applications where we need collaboration means there are various lengthy activities. For example, there is a data storage requirement, there is a data acquisition challenges, there are data management policies to be adopted, there are data integration issues, and if it is also related to data mining, visualization. So basically these all kind of collaborative activities are falls under the category of data sciences. Okay, so and any activities where we need various participations, so that is also a data sciences. Any activities where the scientific workflow is important, because scientific workflow means where we need to follow some specific methods, computational algorithms to draw certain conclusion. So what you can say, basically what I can say, like data sciences are something which are driven by cyber infrastructure, which are oriented by crowd science, which are oriented by large scale scientific methods. Then only we can come to this particular paradigm, which is basically started as a science but now establishing as a technology. Okay, so if we see the what kind of data which is the part of the data sciences, so you can see that every domain is having different perception of observing the data. If we see from the mathematics point of view, so for us, as a mathematician, data is real number, rational number, integers, imaginary numbers, etc. If we see as an IT people, so for us, the data can be bit, byte, boolean, floating numbers, alphanumeric things. Data can be certain entities as a list. Data can be some complex data structure. If we see as a statistics person, so for us, data can be nominal data, ordinal data, ratio, interval. So this is all different types of data. And suppose we have a very raw data where we need all these perceptions to process it. So if IT point of view, we can consider that data maybe as a Boolean data or integer data. From mathematics point of view, suppose if it is a rational number. From statistics point of view, suppose it is a kind of ordinal number. So they have their own significance in their perceptions. So how to develop certain data processing capabilities so that we may address all these three different perceptions. So from mathematics point of view, from statistics part of view, as well as in terms of IT perception, we need to address it in a very different way. But what we are looking here, like we cannot run three parallel methods. It would be good if we are taking the combined approach so that one simple process can update the data and its value in these three different domains or three different directions. So that is basically the challenging thing. Okay, so you can see that from where the problem starts. So here the problem start at this particular time when the data is actually a asset of a multidisciplinary field. So for in the previous slide, you can say that one person is observing data as a rational number, another person is observing data as a some kind of ordinal observation. So third person is observing data is nothing but it is a Boolean entity. So how to update that data, how to process that data, how to interpret that data in certain common algorithms so that these all perceptions can get matured. There should not be any conflict. So this is something which is challenging if we are observing the same simple data problem in terms of a data scientist. Okay. So other than this, you can see that there are various way of observing the data. So sometimes data is raw fact, sometimes data is some means they are having certain important observations. So sometimes data is indicating certain important knowledge, but sometimes the data is just a simple thing. So basically, you can say that when we are talking about the multidisciplinary field, the simple data, they have different values to different directions. So how to preserve those values with minimal effort, that is basically the challenging thing. Otherwise, if we go, so for every domain, this is the very common journey of data. So data can be gathered as a signal, then it can be considered as a data element, then processed as information, then attained as knowledge, and finally established as wisdom. So this is the common journey which we all need to follow. Okay, so although the data sciences are committed towards supporting this common, this very traditional data journey. So all the data science techniques, they are basically trying to facilitate this transformation of data from information to knowledge to wisdom. Okay, so this is the data information, knowledge, and wisdom approach. This is the you can say that it is the core of the data sciences. So all the practices are developed in such a way so that we can able to make this particular journey more feasible, more accurate. Okay. So I am moving towards with some other details. Okay. So now see what is the correlation between data sciences and big data. Okay. So you can see that there was a huge transformation of data generation. So you can say that whatever data we generated in the previous years, maybe the data generation of the rate of the complete year is now became the data generation of a single day. So this is the very unbelievable truth, but we have to see. So and you see this very much popular quote like uh, we are droning into the in the information, like lot of data is available, it is flooded, means every domain is flooded with the data, but still we are lacking knowledge. So where is the fault? Like earlier there was no data, like if you see the late 90s, and then data acquisition was the challenge. How to acquire data, it was the biggest challenge. But you see nowadays, like after this all these 2000 development, after 2010, there is data acquisition is not at all challenging. So we are generating huge amount of data every day, but how to generate information from that data, it is really became challenging nowadays. So here the importance of data sciences are became more and more prominent because the whole situation is changed now. Okay. So what are the types of data analytics? So how to utilize that data? So once you see that there are multiple, means there are many data, means there are a huge availability of data. So how we can utilize those data? So first term is descriptive analytics. So descriptive analytics means we need to just describe the data. So that is the very simple operation which we can perform. Okay, so for example, like you have to just understand what is happening. So you can see there are various plots, statistics, alerts, that can become useful here to be a part of descriptive analytics. So if you are taking the example of your maybe some smart home example, there we are taking the daily consumption of fridge. So you can see that where the consumption is high, where the consumption is moderate, something like this. So this is one type of data analytics. Okay, but you see, so descriptive analytics means we can describe it more efficiently if we see what is happening in the working days, what is happening in the non-working days. So in this way you can get more and more insights from this particular data. Okay, then there is the another aspect which you can deal with that data. It is diagnostic analytics. So diagnostic means we have to see like why did it happen. So here you can there is a graph between air temperature and energy consumption, and you want to see like why it is happening, like why the value is, and the value of energy is more towards the working day or more towards the non-working day. So you diagnose that working day is having heavy consumption and non-working day is having less consumption. Okay, and then you can also here go ahead with some kind of modeling part. Then there is the third one, that is predictive analytics. So predictive analytics means we are more concerned towards the future part. So we want how it will happen in future. So there is the role of machine learning. So with the help of all existing practices, if we are trying to get some future pattern, then there will be means a kind of preparation we can plan. And fourth one is the perspective analytics. So perspective analytics means we want a stable and mature understanding towards whatever is happening. So if we are receiving some peaks like this, so we have to see why the peak is there, what kind of precautionary measures has to be taken for that particular peak of this data. So basically there are four aspects, like descriptive means what happened, diagnostic means why did it happen, predictive means what will happen in the future, perspective means what should we do about it. So perspective means having more stable knowledge about the things which are already going on. So these are the four different types of data analytics which are very likely possible. Okay, if we see one of the literature, which is a very good literature available in data sciences, so according to this, they claim that basically there are two era of data sciences in terms of analytics. One is explicit analytics or descriptive analytics, and second is implicit analytics or deep analytics. Okay, so you can say that if we see the explicit part or descriptive part, so it includes reporting, statistical analysis, alerting, and forecasting. If we see the deep part, so it includes predictive modeling, optimization, perspective analytics, and actionable knowledge discovery. So these are basically a step-by-step process, you can say that. So they are based on in terms of visibility, automation, and state-of-art capabilities. And here basically we are observing like how the degree of complexity and degree of intelligence and values are increasing. Okay, so so here basically the in the first say, you can just see what they are claiming. As a metaphor, they are claiming that sighted people recognize elephant. So obviously if we can see, we can easily recognize elephant. So whatever is this, like reporting, statistical analysis, alerting, and forecasting, it is simply as same as recognizing the particular elephant. So there is nothing very you can say that important. Okay, but here you see the metaphor is blind people do not recognize elephant. So what we can do for that, like something if it is totally out of scope, how to explore that, how to utilize that, for that this implicit analytics or deep analytics are important. So basically this is the way how the things are improving. Like earlier we were satisfied only with the forecasting, but now the forecasting is something which is not new, which is not very surprising. It is something which is the bare minimum requirement. What we are now struggling, we are struggling for the predictive modeling, optimization, perspective analysis, and then finally to gather the actionable knowledge discovery. So this is the expectation. So earlier the expectation was only towards the descriptive analytics, but now the expectation is towards the deep analytics. So this is the way how the data sciences are, means how the data science is creating its importance to the overall domain. Okay. So similarly, there is a life cycle which is also very much addressed by the data science. So basically, it is data to insight to decision. So I think it is there. Like the goal is basically, you see, how and why did it happen? The answer is modeling and experimental design. Okay. The goal is what happened. The answer is historical analysis. So basically, this was the very beginning understanding. So this was the way of working in the early days. So basically, this is the way how we move from data to insight. Similarly, there is the present situation, like the goal is what is happening. So here we are answering it towards the detection and alerting. So that is the at the data level. What is at the insight level? Like we are not satisfied here, means to understand what is happening and to understand how to detect or how to make alert, but our goal is to see the insights. So insights is now we are looking for the driving factors, and we are more interested towards the risk management policies. So this is the present situation. What is the future unknown issues? So the goal is to understand what will happen, and the present answer is to work for the prediction and forecasting mechanism. But what is the deep insight? Deep insight means how and why it will happen. That is important to learn. So to make it more and more justifiable is the thing. Then there is the last basically the life cycle. Like here we are understanding to handle the situation. So what is the best action to take? So here we are developing the perception part. How we develop the perception? We develop the perception in terms of optimization and recommendation. So here, this is the way how the existing technologies are trying to become more and more mature for betterment of the overall you can say that the problem domain, the that particular field of expertise and all. So that was all about the fundamental things. Now I am taking two important areas of data sciences where really lot of work is already done and more innovations are required. So as you understood, it is nothing but to get more and more mature processes. So there are means you are not going to learn something new, but you are going to make your previous practices more and more strong. So it is just to modify the existing techniques. There is nothing like you are going to get exposure of some very different or very new techniques. So the same machine learning basics will help, but the only thing is how to make it more and more mature, how to make it more and more powerful. So as we know that according to machine learning, Wikipedia explanation of machine learning, here we are learning from the data. Okay, so basically what is the challenge here? Like it is a very established field, but now since we want to learn from the data, we want this process to be extremely automated, and we want this process to be extremely context oriented as well as extremely fast. So this is the situation. Okay, I'm taking a very basic example. Like in traditional programming, if we feed data and program, then the computer will give the output. It was the early understanding. But nowadays, if we are feeding data and output to the computer, we are expecting the program. So see how the things are completely changed. So basically, because of the flooded data and the beliefs which we are having, we want to make it more generalized in terms of modeling so that the same knowledge can get utilized. So basically, if we see in simple terms, so earlier it was understood that we will analyze the past data, we'll learn from the past data, we'll use the past data, and we will predict the future. So this was the simplest explanation. Okay. Uh, so what I want to give an insight here, like behind every machine learning success story, there is a data success story. So machine learning is all about data handling capabilities. Okay. And why this machine learning and data sciences are coming together these days? Because every process is data driven. So basically we are generating more and more data today, and we want cost of computation to be as minimum as possible. So to reduce the cost of computation, here the machine learning can help, because we want to reuse our previous expertise, we want to reuse our previous learning, we want to utilize our previous concepts. So we want to reduce the cost of computation, and there are more and more data volume available. So that's why this machine learning is a term which is very frequently used with the data sciences. Okay. So again, you see, like, is it machine learning is the only thing, means how the machine learning and data sciences are related? So there are too much debate. Like sometimes people say that machine learning is nothing but data mining, advanced analytics, and artificial intelligence, cognitive science, or predictive modeling. So basically machine learning is something which is really having a strong foundation in data sciences, so that we have to accept. Okay. And you know that there are wide applications of machine learning available. So not only the personalized medicines, but genomics, speech recognition, and some space missions. So everywhere this machine learning is available. Okay. And evaluation of machine learning is also growing in a very faster way. If we talk about machine learning these days, so the term machine learning is almost going to replace by the term deep learning. So this is the reality in terms of evaluation part. If you see the learning, so we have supervised, unsupervised, semi-supervised, and reinforced learning. So I think you are going to cover all these things in a more detailed way in later of your sessions. I am just taking this to show the strong foundation of machine learning and data sciences. That's it. So basically, what we do in most of the time, like we develop some learning system, and this learning system has to learn some target functions. Okay. So and here it is also a challenge, like how to represent the target function. Okay. So basically with the help of this target function, mean we may able to solve certain problems. Maybe it is a classification problem, or maybe it is a prediction problem. So this is the way how we learn with the system. Okay. Then there is a concept of training versus test distribution. So basically we divide the data in two terms. One is the training data, and second is the testing data. And if the examples are not independent, so we need collective classifications. And if test distribution is different, we have to go with the transfer learning. So transfer learning is a new term which is coined just few years before, where we are using the expertise which we learned from one type of test data or one type of data. We try to impose that learning with another, with some another set of domain, or the another set of data. Okay. So basically I think whatever time I have, I can quickly go for some other details. So I'm taking one example for prediction. So like if we see some kind of scenarios, like if it is a utilization of some household item, so we can we want to predict the energy consumption of the fridge. If it is a coin, so we can see the denominations of it. If it is a house, we want to predict the price. If it is an image, so we want to recognize that image. So these are the problems which can be fed to the machine learning problem or a simple data science problem. So basically what we are going to utilize here, there are various features. So these features we want to use for the particular prediction. So whatever is our target variable, that is basically the prediction. It can be based on certain mathematical terms, and that mathematical term is basically, it is taking certain features for the analysis. Okay. So if we want to predict the energy consumption by the fridge, so the features may be uses the weather. If we want to check the denomination of that particular coin, so we can take the diameter or weight. Accordingly we can predict. If we want to predict the house price, so we have to see the location sizes. If we want to recognize whether the image is of cat or not, so we want pixel value. So basically the features are very important. And you see, like, there are certain aspects where we are using the numeric data, like uses and weather, and we want to predict the energy consumption, so they falls under regression category. Similarly, in terms of size and location, we want to predict the price, so it is under regression. And if we want to, if there are certain features, and with the help of those features, if we are trying to match it with some already existing classes, so that is basically the classification problem. So the question is, how do we predict? Okay, so in general, in present practices, means, or you can say that in general, as a conventional practices, they are rule based. So any physics law you can apply it to predict the energy consumption. Any manufacturing specification you can apply to predict the denomination of a coin. Any real estate agent expertise, belief, understanding you utilize for the prediction of house prices. So these are the things which are having rule based. But what about the prediction in terms of cat or not cat? Do you think some rules are available where certain values of pixels can help you to recognize any image as cat or non-cat? No. So basically, in most of the times, when we are, there are no such rules exist. What we do, we first use the data for the training purpose, and later we establish that information as knowledge. Okay, so there are various these kind of things. So what you can say, all data sciences are running in two parallel tracks. One is the rule based, okay, and second is the data based. So since we have already understood, like, data sciences is not only data driven, there are various mathematical concepts are also there. There are various domains which are supporting it. So basically they are rule based as well as they are data based. Okay. And simply, if we match it with the machine learning track, so basically sometimes it is classification and sometimes it is regression. Okay, so these two are the very common things which we are going to explore. And as I told you already, like, how the machine learning problems become the data science problems, because in machine learning, still I say that we are working at very beginning level. So maybe the processes are not enough mature. But when we see in the data science perspective, we want to make them more and more mature, more and more stable, so that it can be used as a generalized model. So this is the way how machine learning is now became a subset of data sciences. Okay. Okay. So in general, for any data science problem, first step is to formulate the problem. Okay, so formulate the problem means what do you want to predict, or what you want to get the insight from this particular knowledge. Okay, or if you are want to correlate something. Okay, so what data we can use for this? So suppose we want to predict something where the data is X, and with the help of X you are going to predict the value of Y. Okay, so basically with the help of some uses pattern, you want to predict the energy consumption. Okay, similarly, if it is an example of a house, so number of rooms, conditions, location, size can help you to get the idea of the price. Okay, then there is the next term, that is to explore the data. Okay, so if we see what we do basically in the data exploration part, so we see basically it is nothing but the descriptive analytics, where we see what are the variables available, maybe individual variables, and maybe different variables in terms of their relationships. Okay, so you have to understand like how these variables are related to each other. Then in this stage only you can use all the descriptive methods to see if there are some anomalies, some outliers. So we have to understand whether these are useful, or maybe they may be completely useless to us. After that, definitely if we are treating these kind of values, so it is nothing but we have to see how to clean the data. So data cleaning means we are handling the missing values, outliers, spurious values, anomalies. So we have to do that. and then we can convert the data types in various color coding, in various codings, it's a kind of encoding for simplicity purpose so that algorithms can work efficiently. So that is also desired. Okay, there may be various way of doing it, so we can do that, the coding part. And then there are the role of feature engineering comes. Feature engineering means we have to see like what are the observations. So do we collect those observations, or do we recognize any data element as a part of feature? So basically we if it is like this, if we are collecting that observation, so it is basically the constructing of new features. We can transform it or we can select it. So after feature engineering, we are basically looking for the models. So models means how the rules can get adopted. So sometimes you will feel that it is a linearly connected, so linear models can help. Sometimes you see that it is a tree based models. Sometimes you see it can be a simple classification model where the support vector nearest neighbor or Bayesian network can work. So basically we choose and fit the model. Okay, and lastly, we have to see the evaluation of parameters for that particular model. Okay, so here the question is how we can develop a good model. So good model means we have to avoid the underfitting and overfitting problems. Okay, so underfitting and overfitting problem should have to be avoided, and finally we can get the good model. So basically we this is all about the machine learning way of working. The same comes under data sciences. The only thing is how we can make them more stable, more powerful, and more generalized towards very different domain. Okay, so later, let us see the how the model performance can be done. So there are cross-validation options where we choose the training set, and then that training set can be used to train the data, and finally we make the testing feasible after this. There are very conventional evaluation measures. So as far as the machine learning aspects are concerned, these evaluation measures are really a breakthrough. So they are going to be utilized again and again to see the evaluation of various performances. Okay. Okay, so I'm coming to the next point now. Yes. So that was all about the machine learning part. So these are the core practices which we need to adopt with better options through the help of the various interdisciplinary aspects of data sciences. Similarly, the data sciences are also emerging as a new era because of the present situation. So what is the present situation? The present situation is a situation which is caused by the emerging big data. So you can see that how the data is now creating a problem, or how the data is transforming the whole research understanding. So earlier the data was at rest, means you were free to store it, maybe to create a data warehouse and maybe use it for later purposes. But nowadays you see the data is initially available in motion. So basically data is arriving to us in a very faster way and we need to process. So it is basically the streaming data. So here we have no time to store, here we have no time to wait, think or process, but immediately we need to respond. So that is something which is challenging. Now you see there are variety of data available. So data can be structured, unstructured, or it can be multimedia. So the question is, for a single query, how to take these three observations and finally make a collective decision. Then similarly the data is carrying veracity part. So veracity part means most of the time you see the data is in doubt. So data is having inconsistency, sometimes the data are incomplete, sometimes the data is having latency issues, and then data is having multiple values. For example, and it is temporal also, like if I'm using a travel app, so I'm waiting for my vehicle, so for that particular time that data is useful to me, because I am observing the taxi location. But after a few minutes, that data is completely waste to me. So it lost its value. So we have to see that how to utilize the data in terms of its value. And the value is basically very much temporal entity nowadays. So basically, these are the important things. Other V's are like variability part, like data is constantly changing. So we have to see that how to observe the data at any particular instance, because maybe in next instance the data value will completely changed. Then you see the data is viscosity. Viscosity means basically we have to see that the data is having different meaning at a different time domain. Okay, similarly, the data is flooded with virality part. So we have to see that if the data is useful, if it is not viral, means the data is having more information if it is new. But if the data is having this virality part, so it is not basically any information. So you are losing the information if it is become more and more viral. So the data may be precious if you can utilize it at the very beginning moment. So that is, there are so many things. Similarly, the volatility part can also be get utilized. So these are the issues which were not addressed during the data mining phase, during the machine learning phase, but these are the issues now became a very prominent research challenges. And data sciences are basically addressed, means towards handling also these issues. So as I am repeating it again and again, so basically it is making all the data existing data engineering process more and more mature in terms of various aspects which we are facing in every day. So I am highlighting one more aspect, like you understand it, like what is data in motion. So data in motion means data arrival speed is too fast, data is not going to stay with us, we have no time to store, and it is unlimited. So there is no limitation of storing it. So what we need to process it as quickly as possible. So that is important. Okay, I'm giving you one another example. So data stream, I think it is clear. So data stream means data which is coming as a part of infinite sequences of data to us. Okay, so and the important thing is the latency is millisecond. So if you want to make any decision, you have milliseconds or microseconds availability of time, and you have to make your decision. uh, what other issues are, like sometimes the decisions are not based on one data source, but you have to take the data from various sources. All the sources are generating it in real time fashion. You need to fuse them, and after mixing all those observations, you have to make a collective decision. So how these data fusion can make possible, so that a collective decision has to be taken. Okay, so it is some, I think with the help of this figure, you can see earlier it was the first figure like this, like it was a batch processing task. Now it is completely stream processing task. So all the data mining algorithms, all the machine learning algorithms, they were conventionally developed for the batch processing systems. Now they have to be transformed for the stream processing system. So here the data science role are very important, because definitely we need a lot of domain constraints, domain information to transform such algorithms from batch processing environment to the stream processing environment, so that their own issues we can address without having any conflicts. Okay, I'm discussing this last issue, which where the data sciences are playing a wider role. That is a concept drift problem. So concept drift problem is, it is a very common problem nowadays, and I'm just giving you one example. You just recall your first experience of mobile devices. So if it is early 2000s, so in early 2000 we used the mobile phones for calling purpose. Okay, so that was the Nokia model we used, and the manufacturer were also addressing the same issue. Later in 2005 to 2010, the SMS kind of things became more and more popular. So it was not only to make the calls, but also to share the text messages. Later in 2010 to 2015, the camera part became very important. So we started purchasing mobile not only for the call or message but also for taking the picture. So it was the camera which was which were very important. You see, the nowadays it is the COVID era where people are buying mobile to use internet. Maybe if there are 4 kids at their home, so they are for online learning, it is very difficult for everyone to buy laptops, so they are buying mobiles to just access the internet for these basic purposes. So what is this? This is the problem of concept drift. Concept drift means same device. Earlier it was for audio call, later it was for audio call with text messages, then it became a camera, now it became a internet device. So this is the concept drift problem. Means the concept of that particular device is changing. So basically the behavior of that particular device is changing. The expectation of users are also changing. The overall utilization of that is changing. So what is this? This is the concept drift problem. So the idea is how we can make sure that there will not be any new requirement with this mobile. Maybe after 10 years we are using mobile device as our health monitoring system. So in our mobile device we are monitoring our blood pressure, we are monitoring our physical activity, although it is started, but maybe it is recording our pulse rate, it is recording all of these things. So maybe after 10 years the mobile device is not only for internet uses, but it is also our health manager, and it is keeping our health updates with some health organization. So it is updating something like this. Or maybe it is you can imagine there are a number of future applications. So basically this is the concept drift problem. So the idea is how to understand these concept drifts, how to predict these concept drifts, and how to make our models ready to adopt these concept drifts. So I'm taking one very simple example so that you can see how it is challenging in machine learning or data sciences. So like suppose we are using SVM for classification of some data, maybe positive class, negative class. So you started with a hyperplane. Okay, due to concept drift, after some time the data get changed. So your previous hyperplane is obsolete now. So you have to choose a new hyperplane. Similarly, after few seconds, again the data distribution is updated and you need a new hyperplane. And again you need a new hyperplane. So my question is like how to develop a classification model. You already know like it needs training and testing like this. So you develop your classification model accordingly. So this what is the cost of adaptation? Like here you developed one classification model, here it is adopted with new data, here again it is updated, here again it is updated. So basically concept drifts are very challenging because whatever we learn with the previous data, it become obsolete for the new data. Like for example, if you are your training data is daytime data, suppose weather data is a daytime data, so definitely it become obsolete if you are testing it for some nighttime constraints, weather constraints. So it is something very difficult, and you know that there is substantial training time required, and once the training completed, then only you can test it, then only you can get your model accepted. So these are the challenges. So presently there are a lot of applications struggling with the concept drift problems, and early development of machine learning algorithms, they are not strong enough to handle these concept drift algorithms. So what we need adaptive learning, and this adaptive learning should fit as per domain requirements. So definitely domain expertise is required, and lot more support is required to make our learners adaptable for near future, to make our learners quickly adaptable for the changing situations. So here also the conventional machine learning algorithms are facing a lot of difficulties, and that is empowered by the use of the data sciences tools. So finally, I am summarizing the whole data science conceptual map. So basically you can say that there are n number of complexities, there are n number of intelligence which is desired. So so any domain specific problems has to be taken, and you can see that it is nothing but data driven discoveries, where the important pillars are basically mathematical and statistical foundations, and there are so many social issues like privacy, security, and trust. Within these two, there are many more data and knowledge engineering phases. For example, we want behavioral and event processing, we want data storage and management systems to work upon. We also want to see the quality factors of the data, then data modeling and representation issues are there. Data analytics and learning possibilities has to be explored. We also want to design some kind of simulation so that the experimental design can get implemented. We have to also see how the high performance computing can help, and we have to also see how the maximum as well as optimum uses of infrastructure can be facilitated. So basically all these things are there. According to all these things, we can see the value impact of usability, and finally from data to decision to action has to be explored, and finally the output has to be delivered. So this is the whole data science conceptual map, where not only the data engineering but security aspects, but mathematical and statistical aspects has to be incorporated for the final decision making. If we see the overall data industry, so basically you can see that there are many aspects, like it is for communication, it is for optimization, it is for decision support, it is for value added, it is for storage management, it is for transferring it, for processing it, for servicing it. So basically this is the whole task or services of the uh, data which is desired, and it can be used in various sectors which is available in the outer shell of this particular diagram. So this is all where the data sciences are placing, means creating its role. If we talk about the tools, so we need a cloud infrastructure for that. So Apache, Spark, and Hadoop, they are very much supported for this kind of cloud
Uh,
infrastructure.
Hello, ma'am, Sonali, ma'am.
Yeah,
Uh, yeah. So, ma'am, last 10 to 15 minutes they are reserved for
yeah, yeah. I'm
questions.
just, yeah, I'm five. I take 5 minutes to
Okay.
conclude.
Okay. Thank
Okay.
you.
Okay, so basically we have to see how the applications can get integrated. Then there are the tools which are required as a master data management tools. Then there is a separate list of data preparation and processing tools. Then we have a category of data analytics tools. Then we have visualization tools. And other than this, there are core programming tools are required so that all the algorithms can get implemented. We also need high performance computing environment. Then for reporting purpose, business intelligence tools are required. Similarly, project management tools are already there because we are working in a multidisciplinary era. Social networking is one of the key source of these data transmission, so that is also desired. If we see the future of data sciences, so basically the ultimate goal which is required is to replace the human brain with some data brain. So that is the future. We also want to see like how the invisible data can get explored. We also want to see the a very different kind of algorithms list that can be cross disciplinary. Okay, we want to establish new way of data representations. Okay, then at the hardware side, there are new storage requirements, and there are new way to access it, and management tools are required. Okay, then we have to develop more and more strong learning capabilities with the help of mathematical, statistical, and analytical point of view. Then finally, we have to build up with new intelligent systems so that we can make the world as a completely new world. Okay, so this is all about the future of data sciences. So I am concluding here. So I have taken all these pictures and these learning material from various sources. So I would like to acknowledge all the anonymous writers and some very interesting blogs, because data science is a new field. So if you are doing this Google search with the word data science, you will not get enough literature. So maybe some supporting materials can help. So this is all about my experience with the data science. I started my career with data mining, and now I am working for various new paradigms of data science. So now I am free for the question answer sessions.
Thank you, Sonali ma'am. So there are some questions from the participant side. One of them is, uh, can we integrate deep learning with big data?
Yeah, basically, if we see the image data, so this image data is one of the very common data format. So deep learning technologies are dedicated for efficient processing of image data. So you can say that it is already there under the deep means under the data big data techniques.
Okay. And another question, ma'am, is there any other real life example of constant drift problem?
Uh, yeah, there are many examples. Like suppose we are like COVID example, let us take. So COVID examples, if if the certain treatment they have explored for some countries, like very different environmental factors, like European country, and the same treatment if they are expecting from Indian reasons, so may not be possible, because it is entirely different. Indian scenario is different, weather is different, hygiene parameters are different. So for this COVID problem, although it is a global problem, but you see there are various local factors, and they defeat the theory of one location to the another location. So that is the problem here. So concept
Ma'am,
drift means model is working in one setup, but it is going to fail in another setup. So how to upgrade the model so fast so that it can be universally applicable to all the situation.
ma'am, another question is, how do we assess the degree of virality of data, and how we can distinguish between the useful and not so useful data?
See, you can see the means it is something where there are no standard answers available, but I can see in my own way. Like if something is happening, so all these news channels they are covering that particular incident, and it is valuable for them if they are the first one to cover it. So maybe they can claim more TRP, or they can take it as their business benefits. So virality means the data is losing its value. So utilize the data when at the time of emergence only. So there is no as such standard way to defeat the virality part. But yes, definitely with the help of certain, you can say that data security mechanism, we can control the virality part, and we can keep the value for some specific purposes only. So if something become viral, it lose its value, and maybe it can go in a wrong direction. So maybe certain ethical accessing mechanism or some legal cyber law issues can reduce this virality part, and so that we can make it more meaningful for some target domain itself.
Okay. Ma'am, next question is, what is the difference between balanced and unbalanced data, and how unbalanced data can affect the feature engineering?
Okay. So basically, what we do in feature engineering, we understand each and every data entities, and then we rely upon those data entities for certain decision making. So we can take those features which are prominently available in all the samples. So if suppose if for example, like if I am believing on certain feature, but in most of the samples that particular feature is not available, or if it is missing, so that creates imbalance of that particular thing. So basically what we can do, feature engineering is suffered with this data imbalance problem. So we need to assure that data should be balanced enough so that we can rely upon any of the features freely to develop certain models based on that.
Ma'am, there is very interesting question again that for concept drift detection and outlier detection problems, the evaluation matrices are same as a standard classification, or we use some special criteria for the same.
Actually, no. If we see concept drift problems occur with the streaming data, right? So when the data is streaming in nature, so all the conventional classification parameters, means evaluation parameters, they can serve the role, but there are certain specific evaluation parameters we use. They are known as kappa index and temporarily kappa index. So it is basically, you can understand it like this: like there is a ideal value. Suppose I am taking the room temperature as a 25 degrees, is it's a ideal temperature, okay? And sometimes it is coming for my day-to-day observation, sometimes it is dropping maybe till 18 degree, or maybe it is going up till 30. So if I am evaluating the AC, so whatever is the AC performance is, I have to check it with the help of the ideal value, that is 25. So similarly the kappa index will work. So basically the kappa index is, it is taking the ideal accuracy, and it is taking the various accuracies coming across different set of conditions, and try to see how much it is different from the ideal one. And there are certain differences which we can accept within the threshold, and rest we need to discard. So this is the way how we take measures of the streaming data.
Next question is how business analytics is related with data science, whether it is part of data science or, I mean,
Yeah, basically, see, the ultimate goal is to, uh, like from data, we are moving towards information. From information, we are moving towards knowledge, and finally towards wisdom. So, wisdom is nothing but establishing certain practices, policies, some work style. So, ultimately, at the top of each and every data science role, there is the ultimate role of policymaker. So basically, according to different domains, if business and business analytics or business experts are working, they can make it more firm in terms of policies, in terms of work practices, or in terms of business tactics, so that for next generation it can become the total environment for them to initiate any further task.
okay. Ma'am, there is one question regarding morality, that what are the different moral practices and ethics we should have while dealing with the data?
Uh, if we see, like there are many aspects, like in the present situation, if we are considering the data in terms of veracity part, in terms of virality part, in terms of viscosity part. So basically our responsibility with that to address them in an appropriate time, in an appropriate way, with full authentication, then only the morality part can get addressed. So suppose if some data is required at any time t, and unnecessarily if you are delaying that data, if you are not producing that data at time t, and there are some time lag involved, so it becomes useless. So again, it is a breach of our responsibility for that particular domain. So basically, data is something, it is invoking so many actions nowadays. So if you are, for example, like if you are managing the automated ICU surveillance system, so you can understand how the data is important. Data is running a life. So all the vital parameters are governed by the data. So if you are missing in any of the data processing step, so that becomes our responsibility, and it can be fatal. So basically, data is something which is, it is everything nowadays. So we have to be very loyal in all the aspects of data handling issues.
As the time is limited, I will take this question as the last question. So, ma'am, one more question. That is,
Yeah.
once we transform the data, do we need to retransform it to arrive at the results?
Definitely, data transformation are basically, means more and more data transformations are required. Like sometimes data at one stage may become information for other stage, but later these information again became the data and more transformations are required. So you can say that, as I told you, it is like a maturity of the process. So every time for more and more mature analytics, we need more and more transformation over this particular data.
Okay, thank you, ma'am. And from on the behalf of organizing committee and Department of Computer Science, I thank Dr. Sonali Agarwal, ma'am, who gave the lecture on fundamentals of data science. As the participants are also mentioning in the chat, the session was very nice, crisp, clear. The slides were very well arranged and very, informative and funny at the same time. So, thanks, ma'am, for giving your valuable time, and we will hopefully reach you out in future as well for such
Okay.
undertakings. Thank you, ma'am, once again.
Okay, thank you, and all the participants. All the best for all your future endeavors. I would be happy to help anyone for any kind of research initiatives. So you all are free to contact me, and all the best for your future. Thank you.
This is Dr. Mohammed Sajid, ma'am. Thank you very
Yeah.
much. Thank you so much for this interactive lecture. Thank you so much. And dear participants, our next session will start from 2:30 p.m. Now all of you can leave. Thank you. Thank you.
Okay.
हाँ नहीं अभी सबको सब हाँ वो